47, the 09, whichever MTEL math exam you're going to be taking. This is an exciting time. These videos are help you get ready. Review a quick concept and then study it, practice it, and then when you see it on the test, you're going to have success. If these videos aren't enough, you can obviously do the private one-on-one tutoring, or you can sign up for one of the MTEL math workshops in Harvard Square, and those are fun, and those are also a really positive experience for all the teachers that are involved. And there are Harvard Square MTEL math workshops coming up this December, this January, throughout the whole year, and there's also MTEL math workshops that are in other parts of Massachusetts. So I do encourage you, if you're interested in one of those or the tutoring, to contact me with the contact information here, or just enjoy this video and let me know that you enjoyed this video by saying, hey, this rocked. Alright, let's start. Let's get going. Think about this problem. One way to think about this problem is as a fraction problem, a part-to-whole question. So let's start there. That's very important that we have a starting point. Here I have one triangle. It's figure 1. It's the whole thing is left blank. So out of my whole, there's no parts that are shaded. So it's just 0/1. Now this next one, it's made up of 2 parts and 1 part is shaded. So that's 1/2. The third one is a little trickier. The third one is, let's see, this part is shaded and this part is shaded. Now, it's not 100% intuitive, but I've seen 3rd, 4th graders do this. Let's just take our pizza pie and cut it one more piece, so now I have 4 congruent shapes. So I think then at that point it's a lot easier to say, hey, there are 4 parts of which 3 are shaded. This one's 3/4. 3/4 of this triangle here are shaded. And we could do the same thing for the fourth one here. The fourth one, however, is divided into smaller shapes, and if we followed out that same pattern, dividing the larger shapes into smaller congruent shapes, we come up with that, this one has 8 parts, of which 7 are shaded. And let me just show you really quickly how to do that on the actual problem itself. Just so, I think it's important just to see this. All I needed to do was draw the line here, so I had 4. 3 out of 4 now are shaded. And this one right here, this just means me going and picking the smallest shape that's there, the small triangle, and dividing the whole shape into small triangles. So now figure 4 is made up of 8 parts, of which 7 are shaded. So I'm on my way to solving this problem. I do have a method to solve this, but if we think about this now in terms of algebra, algebra means that we're looking at patterns. So is there a pattern here? 1/2, 3/4, 7/8? I think there is. I think if we could even put these in a table of values if we wanted to. I don't necessarily think this helps, but figure 1, figure 2, figure 3, figure 4, we could say this is 0, 1/2, 3/4, 7/8. This is definitely one way to organize it. I don't think this is totally going to be 100% helpful because it leads to a bunch of other things that you might be thinking of slope, you might be thinking of a whole bunch of other things where you would use a table of values, but it is a pattern, and so it definitely does involve algebra, and we could use that to solve it, but we're not going to. Let's continue with this idea here. I see the patterns, I have the visuals. One thing I notice is that the denominator in each one of these cases is doubling. Does everyone notice that? It's going from 1 to 2 to 3, to 4 to 8. And then another thing I notice is that the numerators is always 1 less than the denominator. So if we were to continue out this pattern, of course we could, take our shape and basically divide the triangles up again one more time, and we would get, doubling the 8, we would get 16 parts, of which 15 are shaded. I think at this point it's more important to find the pattern than to actually divide up the shape. What would be the next one? Well, if we followed out the pattern the same way, we would be doubling the denominator, so that would get us 32, and we would that would be 1 less than the numerator, so in this case it would be 31. Okay, so at the end of the day, I have this triangle which has 32 little triangles, of which 31 are shaded. I'm not even going to try and draw that. You have to use your imagination.
Let's dance in style, let's dance for a while. Heaven can wait.